In number 13, we're supposed to decide the graph of which function is shown. I'm going to make a table of values to help myself out here. X, Y coordinates, we've got, well, if this is 1, this looks like it's got to be a half. So we've got 0.5. Then we've got 1 over 1 and up 2. So we've got 1, 2. Looks like we've got the point 2. Here's 2, 3. Maybe that's 3.5. When x is 3, we get 5. And when x is 4, we've got 6, what is that, 6.5? Now, we always look for the easy ones first. Can I just add or subtract? 1 plus 1 is 2, but 2 plus 1 doesn't give me 3.5. Unfortunately, I can't just add 1 times 2 is 2, but 2 times 2 is not 3.5. I can't just multiply either. So then we look for a clue, and we say, well, what happens when x gets bigger by 1? Every time x gets bigger by 1, what's happening with our y values? Well, this one goes up 1.5, and then from 2 to 3.5, that goes up by 1.5, and 3.5 to 5, it goes up by 1.5. Every time, it's going up by 1.5. I emphasize the word time because that's going to be a key operation. We're going to have to times by 1.5, which another way to think of 1.5, we could have as a decimal, or we could have as an improper fraction, 3 over 2. So when we come up with our equation, how do we get our output variable y? We're going to have to multiply by 1.5, or 3 halves. We're going to have to multiply our x value. And then we're going to have to tweak it, though, because if we throw a 0 in, 3 halves times 0 is not a half. 3 halves times 0 is 0. We'd have to add a half to get a half, so we'll have to add a half. Let's just check one other box to make sure that works. Let's try 3. If we took 3 halves times 3, and then we added a half, let's see what happens. Kind of writing diagonal here. 3 halves times 3, well, that would be 9 halves. And if we add a half, we'd have 10 halves, and 10 divided by 2, well, that's 5. And if we check, hey, yeah, when we plug in 3, we should get 5. So we're looking for the equation 3 halves x plus a half, which lands right there at letter C.